गरीबी है, काश इतना अमीर होता कि इतना समय होता कि आराम से आप यूज कर सको। तो अल्लाह की बात, गरीब आदमी की जेब में 50 रुपए है, खाना भी खाना है, बच्चों के कपड़े भी खरीदने हैं, तो क्या करेगा?
सर ये आप कह रहे हैं।
Every day I get almost 400 to 500 emails, और अगर छूट जाती है तो आदमी ऐसा गाली देता है कि पता नहीं पाप कर दिया मैंने. I just saw in the morning that there was an important mail that was missed, so I just called this AI to just do it as soon as possible.
Good morning, sir. On behalf of MIT fraternity, I welcome you back to this FDP on data science. So we are beginning with second day, that is 11th of January, and we'll continue with Shalabh sir for the first session. The second session begins at 11:30 p.m. AM. So it is request from all the participants to be online by 11:30. This session will end up by 10:50. And then we'll have the third session by Shalabh sir at 4:30 p.m. Right, sir?
Yes. I'm sorry for this actually jugglery, but I am unable to manage my time. I have to shift here and there so that I can.
Sir, you are giving us so much time. We are highly thankful to you for this. And you never say no to my request. I am very much thankful from the bottom of my heart, sir. And all the participants are being benefited by this FDP, and means getting lectures from you is a big thing. And
actually, Anuradha, that is our primary job, to give the lectures. This administration is the secondary thing. People feel more privileged in telling that they are administrator. I don't feel happy in telling that I am an administrator, but then I have to work also.
Yes, sir.
Right. So shall we begin?
Yes, sir.
Right. Okay, friends, welcome to this course once again. So today I'm going to explain you a very important aspect of this R software and then the data handling, and that is about data frames. So you know that when you are trying to handle the data, that can be character, that can be numeric, or that can take different types of formats. Now, when you are trying to deal with the matrix, then you have to, well, in the matrix, actually, if you wish, you can replace a particular element. Yeah, Anuradha, have you started the recording?
Yes, sir.
Okay, because yesterday you forgot, so I thought that I can tell you.
I have recorded.
Right. So in the matrix also means if from the point of view of R, there is no problem that if you try to replace a particular element by a character, that can be done. But the problem will be then you will not be able to do the mathematical operation. Right. So now if there is a need that you want to have a structure of the data set where you can handle characters, you can handle numericals, and as well as you can do different types of operations on it. Like as, for example, if I say you have some students and you have given them 5 sections, and then you have given them marks in physics, chemistry, math. So you are going to create a file in which the first column is going to be the name of the students, second is going to be the sections like A, B, C, D, E, and then in the third, fourth, fifth column, there will be physics, chemistry, maths, and so on. So in this structure, if you try to see, you are trying to deal with both the things. Now, if you try to recall your MS Excel, what do you do in the MS Excel file? Or well, MS Excel is a particular type of file that is created in the software, but you can talk of in general any spreadsheet. You can use OpenOffice.org also to create such a spreadsheet, and another free softwares also. In MS Excel, for example, if I say which is one of the most popular way, your data can be anything. That can be a character, that can be a numeric, or say that can be some combination of both. Right. So now the question is, how are you going to handle the spreadsheet in the R software? So whatever is the concept of an .xls file in the Microsoft Excel software, the same is the concept is of a data frame in the R software. Both are the same thing. So and then if you try to recall in the Excel file, you can do different types of these operations. You can extract a particular data set. You can call a particular variable. You can call a particular row. You can call a particular column. You can hide the columns. You can extract a subset of the data, etc. So whatever you can do in the Microsoft Excel, that the same thing can be done in the are also through the concept of data frame. Right, so that is what I am going to give you here a brief introduction, and the reason why I included after in discussion with Dr. Anuradha Mishra, because you are going to deal with this machine learning topics in which the data is arranged in a particular way. So that was the reason I took this CSV, TXT, and this data frames to explain you. Right, and then towards the end, I will give you a brief idea about the logical operators, which I feel that they are important in the case of machine learning, because you are going to divert your outcomes using the concept of logical operators. Right. Okay. So let us begin our lecture. So you know that when you are trying to combine the data in the R software, then you have a couple of options. Right, which is here C that you know, then C bind that we will do today, vectors and matrices. And similarly, another option here is data frame. So now in the data frame, there is a condition that we can combine the variables which are of equal length. Right, and then each row in the data frame contains the observation on the same unit. So in a simple language, simple example, you can imagine that you have an Excel file where means in the first column you have written the names of the students. So every row is going to wait, and rather everybody is joining, and then my connection is getting lost again and again.
But sir, everyone is means. Are you feeling something on your screen?
Actually, what happened that currently your screen comes forward and I lose my this screen of this PowerPoint. I don't know why this is happening.
I have not shared anything.
Actually, let us be clear. Okay, so okay, so now. So you can imagine that, okay, there is a row here, and then the names of the student along with their marks in the physics, chemistry, maths, and section, they will be written on a particular row. So this is what you have to see. So now if you try to see here, if you try to think, the number of students are going to be the same, and the number of students are going to be fixed. So, and then for every student you are going to write down the name of the section, physics, chemistry, maths marks. So that is why I am trying to that is why I'm trying to say here that this data frame has contains equal observations. Or the data frame, the columns in the data frame, they have got the same length. So the number of students, number of marks in the physics, chemistry, math, they are going to be the same. So the advantage in this case of data frame is that it is a very versatile framework in which you can do different types of mathematical manipulation, graphics, statistical computation, etc. And this is one of the structure in which you are going to input your data also. Right. So as I said, in the case of data frame, you can combine the numerical values, characters, strings, factors, etc. all together. Right. So, for example, this C-bind and matrix, they are also the similar type of thing. For example, if you try to use the C-bind or C function, you can write the numbers as well as characters. But then this data frame also has a particular type of structure, and actually these structure, they are called as objects. So using the command matrix, the data is going to be stored in a different object, and when we are trying to save the same data in the structure of data frame, that will have an internal different structure, or say different this object. Right. So anyway, so now you see, means spreadsheet is not only related to this MS Excel or OpenOffice, or but that is the simply the data file that you get from SPSS or any other file actually. And then the variables which are arranged in the columns in the data frame, they can be factors, they can be numeric, they can be categorical, they can be means anything actually. That is the best advantage of using this data frame. So what I will do here that instead of giving you the theory, I will try to take different operations on some internal data set so that I can explain you what is the function. And surely, yeah, means given the time, I will try to give you here the most popular means operations. So what I will do here, I will try to use here the package mass. For example, yesterday I told you that mass is a package which is which contains the data set sets and all the functions which are related, which were used in the book Modern Applied Statistics with S, right? So this is here MAS and here S. This creates the name of this package mass. So this was the book which was written by Van Bley and Ripley from Springer. And that was the book which was trying to explain how the statistics can be used with the S+ software. Right, okay. So now, first I try to show you here, and then I will try to show you on the R console also. So in this mass package, there is a data frame whose name is painters. Right. So, and so I try to use here this command here, library mass, so that I can upload it. And then if you try to look into this data set here, painters, that will here look like this one. So these are the names of the painters, and yeah, means in India we are not very well, or at least in India, at least a person like me who means I'm not very well versed with the concept of paintings. But if you go to European countries, then there are schools, and then there are extremely famous schools actually. And means I have seen in Germany that every city will have couple of museums which are very popular among those people. And yeah, so there are various variables like as composition, drawing, color, expression, school, etc., which are collected for each of the painting, right? So this is the data set for those things. So you can see here now these are your here rows like Da Udine, Da Vinci, Del Piombo, Del Cerreto, etc. And these are the data sets. So you can see here the number of data for each of the column will remain the same, because for every painter you are going to get such observations. Right. So now let us try to yeah, if you try to look into this one into the R software. Yeah, actually what I will do, I will try to show you this R software part at the end, because otherwise I will have to change the screen again and again. That will create more confusion. But anyway, I have given here the exact screenshot so that you can understand it very easily. The same thing you will see in the R software also, right? So this is how the screenshot on the R software will look like. And if you wish, means parallelly you can start the R software and you have all the files, so you can simply have to copy and paste the same thing and you will get it on your screen, right? And then yeah, now the first question comes here, means I'm trying to think about a situation where you are getting some data from some external sources, right? Somebody has sent you a data file, and now you have to just work on it. So first step what we try to take is that we would like to extract the different types of information about that data set. So how to get it done? Right. So for example, if I get a data set in the format of a data frame, then I would like to know what are the row names, means what are the names in the rows. Right. So for example, in the MS Excel, if you try to see, the rows names are 1, 2, 3, 4, 5, 6, and so on. So similarly, in this case, you can see here the row names are here like this one, Da Udine, Da Vinci, etc. And if you try to see here, this is here the Da Udine, Da Vinci, etc. Okay, one very popular confusion that I would like to clear here, that what are these numbers indicating, 1, 4, 7, 10, etc. So this is like this. This is the first observation. This is the second observation. This is the third observation, and this is here the fourth observation. So this 4 is indicating that the first observation on this line is the fourth observation. Similarly, if you try to take this 10 is indicating that this is the 10th observation on this line. Right, so after that you can count 10, 11, 12, and then here 13. So, and then if you try to adjust the screen size of your R console, then this numbers will be changing, because if you make it more wider, then more number of observation can be accommodated on the screen. Right, so the command to know the row names of the data frame is say ROW, row, and AMES, row names. Okay, one important thing, that R is a case sensitive, means there is mean the lowercase alphabets and uppercase alphabets, they are taken in a different way. Right, they are taken differently. So if you try to use here capital R and then ROW and AMES, then it will not actually work. So you have to be careful when you are trying to use it. Okay, so and yeah, this is the same operation that you will get when you try to do it on your R console. Also, you can see here like this one. Right, so this will give you the information. So you can see here there are 49, then 50, 51 values in this data frame. Right. Now, similarly, if you want to find out the names on the columns, then my command is COL NAMES, and then inside the parenthesis you have to write down the name of the data frame that you are trying to use actually. Right. So you can see here that you are getting here the names like here, composition, drawing, color, expression, school, etc. And now, actually, what is the use of this data frame that I want to illustrate here? For example, if this data frame has, suppose there's 5 variables: composition, drawing, color, expression, and school. Now, suppose if you want to do some mathematical or statistical operations on these variables, and you have 2 options, that you can do such operation one by one on these variables, or you want to do the operation on all the variables at the same time. So, if, for example, there is a function here, summary. If you try to use the summary function on any data set, it will give you some statistical information like as minimum value, maximum value, first quartile, second quartile, that is median, third quartile, and the arithmetic mean. So now, suppose if you want to find out such a summary function for composition, drawing, color, etc., then you have to do it individually. But in case if you are using the data frame, then you can simply write down here summary and the painters. So now what will happen? That such information will be executed on all the columns, and then you will get the outcome. And the beauty of this outcome is as follows. You can see here this composition, drawing, color, expression, they are the numerical value. They have got some numerical value, but the school is a qualitative variable. It has got, say, 5 classes, A, B, C, D, E, F, G, H, like this one. Why write in 5 or 7 classes, whatever they are. So so this R software is automatically deciding that how this summary function is going to be used for quantitative and qualitative variables. So you can see here these 4 outcomes, they are giving you this type of information: minimum, maximum, first, second, third quartile, and mean. But whereas in the case of qualitative, it is trying to give you here the frequency and other options. So that is the advantage of using the data frame, that you are not bothered about the individual variables characters, but you can just operate it and R will take care of it. Right. So this is the advantage of this data frame. Yeah, this is here the screenshot of the same operation. So now the first question comes here: how are you going to create the data frame? Because it is possible that yeah, for example, if you try to see, uh, suppose if I say that somebody has collected the data on the height of say 100 students, somebody has collected the data on their weight, somebody has collected the data on the age, right, of the same students, and they have given you the three different files. So the first thing is this: you can combine the file, and second thing is this: you can choose a particular variables from the three different files, and then you want to create a new data frame. Right. So, so in order to create a data frame, our command is data.frame. That is data.frame. So this will add the different columns, and it will give you the new file. So it is something like this. Suppose you have three Excel files, and you try to copy a particular column from the file number 1, file number 2, and file number 3, and you try to copy and paste in a different file. So that will create a new Excel file with those three columns. So that is the same operation which is done by data.frame in the R software. So let me try to take an example here and then try to show you that what are the do's and don'ts. So I try to take here three different types of variable. I try to take here the numbers 1 to 16. Then I try to take here a matrix of order 4 by 4, and then it is containing these 16 observations, so 1 to 16. And then I try to take another here this alphabet. So in order to create the alphabet, we have a command here LETTERS. So you can see here X will look like this, and Y will here look like this because of the matrix of order 4 by 4 you can see, and Z will look like this here. First 16 alphabet from A to P. Right, so now I want to combine them in the format of a data frame. So you see here, I try to write down here, say data dot frame and X comma Y comma Z. Right, and I try to store this inside a new variable here, whose name I am giving as a data fr. Yeah, just to indicate that this is the data frame. Now, if you try to see how these values have been combined, and this will give you some idea that what are the do's and don'ts and how the R is working. If you try to see here, X was the number from 1 to 16. So this is working here. So now you can see here why I have taken the only 16 values, because 16 values I can show clearly on my screen. If I try to take more, possibly this the font size I have to reduce to a very small extent. Now, similarly, if you try to look at here alphabets from A to here P, they are here like this. Okay, I can share with you all that why I am unable to make a straight line, because you can see here I am writing on this actually board with this pen, so I have to look here and then I have to write on the board. So that is why it means I am unable to write it so properly, right? So anyway, so that is not a big deal. So anyway, so if you try to see here this 1 to 16 numbers and A to say here P, these alphabets, they have been arranged in the two columns. But when you are trying to look at this this matrix, you can see here this is your here matrix like this 4 by 4 matrix, and then this matrix is repeated again, this matrix is repeated again, and this matrix is repeated again, right? So now if you try to see what is this happening, as we had discussed in the basic fundamentals of this data frame, that every column should have the same number of elements. So now it is happening here that X and Z, which are the numbers and alphabet, they have got 16 values. But for this matrix, every column has only 4 values. So it has multiplied itself. And then it has repeated it 4 times, so that 4 rows in every matrix 4 times will make 16 observations. So these are the things which you have to be extremely watchful, careful, that do it according to your actually need. Right. So yeah, so you can see here these are my variables, and this is how the data frame will look like when you try to execute it on your R console actually. And now, so after this, the second option comes here, that whenever you are trying to get a data frame from some external sources, you would like to have a comprehensive information about the data set. So for that, we have a command here, str. Str means structure. Right, so this structure command, str command, will give you the dimension, the name, and the type of each variable. For example, if I try to execute it, and if you try to see here str and then here this painters, it is giving you the information that it is a data frame. It has got 54 observation of 5 variables. And what are those variables? This composition, drawing, color, expression, school, and then it is trying to give you an idea for the int. Int means integer. Right, and similarly you can see here, this is here factor. So it is indicating that composition, drawing, color, expression, they are integer, whereas school is a factor. And then it is trying to give you some starting beginning values, that how these values are looking like, so that you can have some more information. So when you are trying to deal with the factors, actually we have got labels and labels. So it is trying to indicate the labels and labels of those variables. I mean, it is something like this. Suppose you have this data on, say, male and female, and you try to indicate a male by M and female by F. So this M and F, they are the labels, and then you try to assign some numerical value. So this is the structure of a factor variable. So that is what it is trying to show you here. Now, and then this dollar variable, this dollar sign has a particular meaning, that when you are trying to extract a particular variable from there, then we try to write down the structure as name of the data frame, dollar the variable name. So that is why it is giving you here the dollar sign. I will try to explain you that how you can extract a particular variable from a data frame. So this is here the screenshot of the same observation. So now the first question comes here. You have got a data frame which may have many columns, and suppose you want to extract the information on a particular column. For example, if you have got a data set like this one, like as name of the students, and then section, and then here marks in the math, physics, chemistry, and so on. So you can see here, these are the values here. Suppose you want to find out the arithmetic mean of the marks in the mathematics. So that means you need to extract this particular column, and then you need to do mathematical or statistical operations on this thing. So how to extract the data on a particular variable from this data frame? So the rule is extremely simple. Actually, it is not only for the data frames, but for other structure also, that you simply try to write down the name of the object, and then use a dollar sign, and after that you write down the variable. If you try to recall, the same thing we have done yesterday when we were trying to extract a column from the Excel file also. You have used the name of the data set, like a data sp excel dollar, and then put in quotes variable 1, variable 2, and variable 3. So the same thing will happen here. Suppose if I want to extract the information on the variable school. So what I have to do, I simply have to write down the name of the data structure, as the name of the object, which is here painters, and then dollar sign, and then write down the name of the school. Now you have to be careful here that I am writing here capital S as capital, and then all other things are in lowercase alphabets, because actually this is the way you can see here that this school has been given in the data frame. So you can see here in this one. Right, so you have to use exactly the same. If you try to use your lowercase alphabets, possibly R will not understand it, because R is a case sensitive software. Right, okay, so this is how the things are going to actually work. So now, and then similarly, if you want to extract a particular observations, just like in the case of a matrix, then you can use the command for this row and column, and then you can extract a particular observation also. For example, if you want to extract a particular observation from a row and column, so you simply have to write down here the name of the data object, and then the square brackets, and then this row comma column, right? So for example, if you want to know what is the value in the data set painters, where the name is the Udine and the variable name is this composition. So if you try to do it here, it will give you here 10. And if you try to see here in the database here also, you can see here Udine, and then here composition. This is giving you here value 10. So this particular value can also be extracted from this data frame. So that is not a big issue in this. So now you can see here that you can obtain the data on a particular row, particular column, as well as a particular value. Right. So these are the basic things which you try to do in the case of this data frame also. Now I will just try to show you that how you can use this data frame for creating this matrices. Right. For example, if I want to create here a bar plot, so what I can do here, that I can use here this variable. You can see here I have just used a particular column name, which is painters $school. And then, yeah, whatever is the R command for creating the bar plot or the pie chart, I'm just using here, say table painters school, and you can see here it is giving me this here bar plot. And similarly, if I want to create here a pie chart, then it is here like this one, means, yeah, that is the command to create the bar plot and pie chart in the case of categorical variable here, that you have to write down here table, and then you have to write down, yeah, it means if you try to do it without table, then it will give you all the individual values, which is not a good thing actually. So that is what you have to do here also. Right, so you can see here now you can handle the individual columns also, or individual variables also from the data frame without any problem. And yeah, means I'm taking the example of bar plot or pie chart, but you can do any type of statistical observations. And yeah, for example, if you try to recall in Excel, you used to write the column name as A, B, C, D, and so on. So the same thing here is given by this here painters dollar composition, painter dollar school, etc. Right. So that is the advantage of using this data frame. Now, okay. Now, if you try to see here, every time whenever I want to extract here a particular variable, I have to use here this command painters, and then I have to use here dollar. Right, but suppose you are working in a particular data frame, say mass, and then you are just continuously working, you are doing different types of manipulations, then there is a way out that you don't have to write this painters dollar again and again. Right. So for that, what we do here, that there is a command here attach. So this command attach will attach the data frame to the R software, and after that you can call or you can manipulate the different variables just by calling by their names. You will not have to use the command, the name of the object and dollar again and again. Right. So, for example, in the case of this painters one, you have used this here painters.school. But if you try to use the attach command first, then you will have to use only the school. For example, here you are trying to find out the bar plot of table painters dollar school. But if you attach this, then you have to write there only here as school. Yeah. So how to get it done? So for that, first you try to use the command here attach. So attach will, what will do, it will attach your data frame to your R software to the current working profile, and after that you will be able to handle different types of variables without any problem. So if you try to do here this attach, and then inside the parenthesis you write the painters, then after this all this composition, drawing, color, expression, school, etc., they can be used directly without any problem. Right. For example, if you simply try to write down here summary of a school, you don't have to write summary painters dollar school, and then you will get here this type of information. So similarly, if you try to use the summary composition, then you will get here this type of information without writing painters dollar. So actually, these are the tricks which makes your things faster and you feel more comfortable when you are trying to use it. Okay. So, but you have to remember one thing, that once you have used the command attach, after you are done, then you have to remove it also. And in order to remove it, we use the command here detach, detach, and then inside the parenthesis you have to give the name of the this data frame. So what will happen here, that once you have used here attach, then you can use here you can use the variables without giving the data frame dollar object, and then after you use here detach, right, and after that if you try to use here summary school, you will get here error in summary school, and you can see here this is the screenshot. So what is happening, because you have detached it, so now you have to use the painters dollar command again, and then you have to write painter dollar school, right? So that is the first thing. Now, in case if you want to extract a particular type of information from this data frame, how you can do it? For example, suppose you have a spreadsheet where there are 100 students. They have been divided into, say, this different sections, section A, B, C, D, E, and their physics, chemistry, maths marks are given, and you want to know, and you want to extract only the data set of a particular section, say section B, then how to get it done, right? So for that, in the R software, we have a command here, subset, right? So what you have to do here, you have to write down here, for example, subset and the name of the data frame. For example, in this case, what I'm trying to do, that I'm using using the data set painters, and then in the painters, I'm trying to extract the information on the variable school, whose name is F. Right. So what I try to do here, that I try to use here the name painters, and then I try to write down school and double equality sign, and within quotes capital F. This double equality sign, this is the logical operators that I will try to take after a couple of minutes. So this is a logical operator, because you know that when you are trying to use the single operator, and if I write x is equal to 7, that means the value of x is replaced by the value 7. But when I'm trying to write down here the logical operator, like which is two equality signs, then it means that it is a logical operators, and this outcome is going to be either true or false only. So if you try to give here this command, you can see here you get here this type of outcome where it is trying to show you that these are the 4 painters which are belonging to the school F. And similarly means you can add here more condition, and then you can generate different types of queries also, right? And yeah, if you try to do here, yeah, means instead of using the subset command, if you want to do, there's an alternative way also, but it is more complicated in the sense you have to write down here painters, and then within the square bracket you have to write painters, and then double square bracket within the double quotes of a school, and then double equality sign is equal to F. So that depends on you how you want to proceed further. Right, so there is no different, but then subset command is much easier to remember. Okay, so and then similarly, if you want to know from this data set that that what is the part of the data set where the value of the composition is less than or equal to 6. So the sign for less than or equal to here is like this, less than and equal to. This is again the logical operator. So if you want to want to extract the data set from these painters where the composition value is smaller than or less than or equal to 6, then the command will become a subset, the painters, and then the name of the variable composition and less than equal to 6. So you can see here, you will get here this type of observation where you can see here this composition variable has all the values which are less than or equal to actually 6, right? So and now and okay, you know that in the MS Excel there is an option here with that when you go on the columns and if you do the right click on your mouse, then there is an option to hide. So what will happen that if you want to operate on a particular data set and without disturbing the original data set, then you can use this option hide. So what is really happening if I try to explain you in a very simple way? Suppose your data means a spreadsheet contains suppose 5 columns and you want to work only on say 3 columns. So first option is that you try to create another Excel file and try to copy these 3 columns from the first file and copy them into the second file. And then you start working on the second file. Second option is that you just go to the original file and on the top on the columns, if you go and try to right click your mouse, then there will be option there hide. And then in the hide, if you say click on it, then that column will collapse and that will be not visible. And your column names will be shown like this instead of A, B, C, D, E. Now that will become, suppose if you have hidden say column number B and C, then the data new structure will look like A, D, and E. Right, so the same thing you can do in the R software also. So if you want to hide the uninteresting columns, then what you can do here that you have to use the option here select in the same subset command. So suppose in this data frame painters in the school F, suppose I want to hide the third and fifth column. So what will happen here that you, in order to do it, you simply have to use the command here -3 and -5 because these are the third and fifth column. So you have to simply here select and then seize the command to combine the two values together in the format of a data vector, and you simply try to see here -3 and -5. So minus is going to indicate and that you are trying to hide the column. So if you try to do it here, then you will get here this type of outcome, and this is the screenshot here. So you can see here, this is here the composition, drawing, and expression. And if you try to look into the original file over here, so if you try to see here, so I have written here this color, this is at number 3 and school as the at number 5. So they are now hidden. You can't see it, and only the variable number composition 1, drawing 2, and expression 3, they are only visible. So you can do such operations without any problem in the R software here, right? So yeah, if you have anything to ask, you can ask anytime. Right. So yeah. Now after this, I want to give you one more option. Suppose this is just the similar operation. Suppose you have an Excel file of the data of 100 students. So first column is the name of the student. Second column is the section 5 section A, B, C, D, E. And then you have marks in physics, chemistry, maths. Now you want to split the data with respect to the sections, right? You want means because you have got a single file, there are students from section A, section B, section C, section D, and E. So what you want to do, you want to just create 5 different data sets corresponding to section A, B, C, D, and E respectively. So now how to get it done? So in the R under this data frame, we have an option here split. So we try to use this split option, but then I have to tell that how this splitting is to be done. So now means from the common sense, you can also think that when you are trying to do such a splitting, um, if your variable is a factor variable or a character variable like a sections A, B, C, D, F, E, then possibly the splitting can be done easily. If you have a quantitative variable, then it will give you something which may not be really acceptable. So for that, you have to go in a different way. So for example, here in this database, you can see that your school is a factor variable, which has, there are A, B, C, D, E, F, G, H. So what I try to do here, that I try to use then this command here is split on the data set painters, and then I use the variable with respect to which I want to split. So that will be your here painters dollar school. And if you try to do it here, you will get here this type of outcome. Actually, this outcome will scroll down to a couple of screens. So I have just copied like this here. So you can see here, this whatever is the outcome, I'm trying to store it in a say data object splitted, right? You can see here when you try to see the structure of splitted, this is here $A. So $A means is trying to show you all the data set which are related to the school A. And then you have here $B. So $B is trying to give you here the data set which is corresponding to school B. And similarly, if you try to see here, this is here the $C, $D, and this $C and $D, these are corresponding to schools C and D, right? And then you can see here all the data set corresponding to the variables composition, drawing, color, expression, etc. That is there, right? And then similarly, you're here E, F, and so on, right? So this is how, and then G and here H. So this type of outcome you will get here. Then you can split the document. So now you can see here, because we have not attached the data, that is why I'm trying to give here this variable here as a painter.school here, right? If I use the command attach here, then possibly I can write down here only the school and it will work. So this is the screenshot, or you can see here, this is how it will look like on the R console. This is for here A, this B, then C, then D, then E, F, G, and here H. Right. So this is how you can create this. And then, yeah, from here also, if you want to extract a particular data set here, you can simply write down here is splitted $A. Right. So now let us first try to let me try to show you these things on the R console itself, so that you can feel more confident. So if I need to, oh sorry, I have to first share my screen. So you can see here now I have attached here this data set here library mass. Let me try to increase the font size more. Right, it is clear. So if you try to see here this here mass, and this will have a data set painters like this. You can see here, yeah, actually if you try to see, these are the observations over here. Right. So now if you try to find out here this, like I said, summary and here painters, you can see here, come here like this. Right. So after this, let me try to recall what I have done here. I will try to show you the same thing on the R console also. Right. After this, if you want to know the row names of here painters, it will be here like this. Right. And similarly, if you want to know the column names of these painters, this will be here like this. Right. So this will give the names of the column. And similarly, if you want to know the structure of this data set. So that will be str, and then you can see here this will be here like this one. Right. So after this, yeah, and if you, yeah, so now if you try to see here, if you want to extract a particular variable here, for example, if I say here painters and then here dollar, and now I have to write down exactly in the same way. For example, if I write down S, say here only SCHOL, means I'm trying to make a mistake here. You can see here this is null. But if you try to write down here this here as a capital S, then it will come here like this. And similarly, if you want to extract the information on any other variable here, say here drawing, it will be here like this. So if for example, if you want to find out here the arithmetic mean of this here drawing, you can simply write down here mean of here painters, and it will come here like this one. Right. And similarly, I can show you here now. I try to say use here attach and then painters. Just now you can see here, I can write down here the mean of here only say here drawing. And see here, this is the same answer. And now if I try to use the command here, detach painters. And now if you try to repeat this command here, mean of drawing, this will not work here. But if you try to now, if you try to give here exactly in the same way earlier, then it will work. So that is the disadvantage of this using attach and detach functions. Right. So after this, then I have I will try to take care of the subset command here also. So in the subset command, suppose I want to use here the want to extract the names of the painters and their corresponding values corresponding to those painters whose school was F, then you can see here it is coming here like this. And similarly, if you try to change it here, say here A, then it will be here like this. Right. And similarly, if you try to do here something more, suppose if I want to have the data in which the composition is going to be here, say here less than or equal to 6, so I can use here the command this here subset, and if I do here subset composition is less than or equal to 6, it will come out to be here like this. And similarly, if you want to have here, if you want to know composition is exactly equal to 6, then it will give you this thing. And you can see here this three values 1, 2, and 3, they are exactly equal to 6. Right. Right. So, and then after this, right, and now I try to show you here is split. So you can see here, I try to use here the command here split it, and yeah, it will. So now if you try to look at here split it, this will go to a couple of actually screenshots. So it is here like this one. You can see here now you have a different section corresponding to school A, B, C, D, and here F. And if you want to extract here a particular value here, then I can see here split it $A. So it will give you this value, right? And then you can store it in a particular variables also in which you can do the means different types of computation. For example, if I want to find out anything here from this data set, for example, if I store it as a here Z, now Z will here look like this. And then if I trying to find out here the mean of the composition of those school whose name is A, then I will write down here mean Z dollar and then here composition. We'll get here this value, right? So now this is an operation where what are you trying to do? You are simply trying to find out the mean of those values of composition of those painters who are belonging to school A. Right. So you can imagine that in real life when we are in our colleges, suppose we have 5 sections A, B, C, D, E, and suppose if you want to know that what is the average marks in mathematics in the section B. Right. So for that, these things can be done here very easily. Right. And even you can split them into different parts. So this is what I
Sorry to
want.
interrupt you, sir.
Pardon?
Sir, shall I ask one doubt, sir?
Yeah, sure, sure, definitely.
Sir, in this R, should you calculate SD also standard deviation in this chart, sir? Like you are counting mean and
Yes,
median average.
yes,
Is
yes.
it possible standard deviation also?
Yes. I can show you here. Instead of finding out the mean, I can standard deviation is the square root of variance. So the command here is yeah, the command for variance is var, and if you try to take its square root, sorry, like this. I mean the
Then
command
where
for
should I
mean
take
is,
this, sir? All this shortcut
sorry.
prompt like SQRT means standard variation. So is it
No,
any seat is available for, sir?
wait. Actually, yesterday I talked about these functions where I discussed about this absolute function, minimum, maximum. There also I discussed this SQRT. So means this standard deviation is the positive square root of the variance. So in R, you have a command
Okay.
for computing the, actually if you variance. For example, if you try to see here, we're using this command, say here VAR, I can compute here the variance, and standard deviation is simply the square root of the variance.
Okay, very good, very good. Good, sir. Thank you, sir. Thank you.
Right.
I thought there will be command prompt of SD. I think like mean we are
Actually, that you can do. Means if you know how to write a function, that will be just a one-line function actually, and you can simply define that SD is the square root of the variable x, and then you can simply use the SD also. But that will be a user-defined function. This is not defined inside the R, because you see finding out square root is not a very difficult thing in R. And so from the statistics fundamental, we all know that standard deviation is the positive square root of the variance.
thank you, sir. Thanks very much.
Hello, sir. Can you
Yes,
hear me?
yes. Yes.
Sir, in the split function,
Uh-huh.
in the second parameter, you mentioned the condition that means painters dollar school. So all the school related data will be splitted only, right?
Yes.
Is it like, okay, okay.
Yes. Yes. Because it is just like this. Suppose you get
So
an
whether it's possible, sir, to split with the help of multiple condition in the different splits?
yes. Actually, yeah. I don't have time. Means, and actually, this was a quick review. Actually, in the earlier workshop, which another conducted during summer, that was the elementary workshop on this R software, and in that workshop, if I remember correctly, possibly I would have explained. There is well, today I am going to give you a short introduction to the logical variables, but then based on that you can create different types of queries, and very complicated queries in Excel can be very easily written in the R software. That's my promise to you.
Okay,
If
sir.
I had
See.
time, possibly I could have shown you. And yeah, right. For example, I can show you here itself. Suppose I want to know that what are the names of the this here. Okay, I will try to show you in the I think in a couple of minutes when I try to do the logical operators. Right. So in a nutshell, I can share this information that however complicated is query in MS Excel and etc. That will take a very long time to create it, but in R you can just do it in a R in a one line actually. Right. If you try to see here, if I okay, let me to see here. Here variable. Right, and if I want to find out here all those variables which are say smaller than here 10. Suppose that's a very simple query here. I have to write down here this and less than say here Suppose here 10, and you can see here it will give you that these are the values, right? These are the values 8, 0, 8 and 4 which are less than 10 out of this data set. Right, and yeah, means you can also create a query like this. Okay, composition is less than 10, and school is equal to F, and this drawing is equal to 6. So anyway, they will also require the logical operation, which I'm just going to tell you in a couple of minutes or so. And it can be done very easily, right? Did any there? Right, so let me try to come back to my slides. Right, so now I try to give you here one more way to combine the data sets, combine this data frame. Suppose it is like that. Suppose you have 5 colleges and 5 colleges have sent you the data in different files and you want to combine them in the same file. So now there are, when you are trying to combine, that is called merging of the data set. Then the merging of the data set can be done in three possible ways. That you try to combine this data side by side, or you try to say this vertically. They are above each other. And the third option is this: if there is a common variable between the two data frames, then you would like to combine them in such a way so that this merging is happening with respect to the common database. So I will try to take an example here, and then I will try to show you that how these things actually work. So here I have taken, means first I will try to take here this command here, cbind. So cbind actually merges the two data frame horizontally. So I try to create here, you see, a data frame in which I take, say here, 4 values. Is another name is state, say UP, MP, AP, JK, and then their population sizes, like I say this. And then I try to create one more data set, say data.frame, with the same state UP, MP, AP, JK, but then it is here the sample size is equal to this and the survey completed like a yes, no, yes, no. So I've just created a very artificial data set. Suppose there are 4 states in which some survey has to be conducted. So the sample size taken in these different states, and then whether the survey has been completed or not. These are the information which I want to give. So I try to create such 2 data frame and I give them the name DF1 and DF2. So you can see here this DF1 and DF2 will look like this, right? So now I want to combine them. So means horizontally. So what will happen? Suppose I want to combine this data frame. So this data frame should come here, somewhere here, right? So you can see here I just use here this cbind DF1 DF2, and you can see here this is the DF1 and this is here the DF2. Both are combined side by side, right? So it is not a very difficult job. Right. And you can see here this is here the screenshot of the same observation, and yeah, you can see here very clearly this is data 1 and this is here, and this part is here, right? And similarly, if you want to right, and now if you try to see here, one thing I can give you here itself, in these 2 data frame the state is common, right? State is common. So what you want to, and now when you are trying to combine it, you can see here that the state is appearing here and here both. But don't you think a better option is that try to eliminate the common names, and you want to combine the data set with respect to the variable state? So what do you really want? That this population size only should come, could be merged, and then Yeah, means accordingly the data should also be updated. So in order to do the same thing here, I try to take the same data frame here, df1 and df2, and in order to means merge them means horizontally, we have a command here, say here merge, merge, merge. So merge will also do the merging horizontally, but with respect to a particular row name or a column name. Right. So for example, in this case, the state is a common variable in both the data frames. So I can do the merging with respect to state. But then there are many options here, several options here. So command here is like this: merge xy. I mean x and y are two data frame, and then you can see here by or by dot x, by dot y, so that you can specify whether you want to use the the data variable which is in the data frame X or data frame Y. And then after this, there is an option here, sort. Sort is a logical, so that after merging, it will sort the variables also. And then there is another option here, no dupes, no.dups. That means if there are some duplicate observation, they can also be handled. So all these options can be used here depending on your requirement. Right. So let me try to take this example here and try to show you how it actually works. So you can see here, this is your here df1, and this is your here df2, and this column here is the same in both the data frame state. So I try to write down here merge df1 df2, and by I try to write down here state within the double quote. So now you can see here that this data has been merged together and it is automatically sorted, because that is the default option. Sort is equal to true. If you don't want this sort, then you will have to write down here sort is equal to false. For example, I shown you here this variable here, sort. Right, so you can see here that this data has been merged together and it is sorted in the alphabetical order AP, JK, MP, UP. You can see here AP was here 300 years. So AP is here this sample size here 300, and here yes, and AP here was 3000, so this AP 3000 comes here. Similarly here JK here is 4000, so JK here 4000, and then JK here is here 400 and no, so this is here 400 and no. So you can see here all the things are done automatically without any much efforts. And yeah, so yes.
Sorry for the interruption.
Sure.
Can you go to that cbind operation?
Wait.
Yeah. Yes, sir. So here both the data frames are having same number of columns. If they are having different columns, what happens there?
Means I would say that instead of asking me, if you just add one line, you have all the commands here and then try to see, it will create a warning actually. Okay, it will create a warning, and then I can share with you means as a student means I always prefer that yeah, I try to play with the software, that I will try to do all this experimentation whenever I'm trying to learn a software. Yes, that's a very obvious question actually, what will happen if there are multiple number of observations here. So then in R, usually there will be two options, that it will give you either an error or a warning. So warning means, okay, I'm trying to add it, but then you have to be careful, because in data frame, the condition is that all the columns should have the same number of values. So I have not done it, but from the conceptual point of view, because I know that in the creation of the data frame, every column should have the same number of observations. So if you are trying to take a df1 and df2 which have different number of columns, possibly it will give you error. But unless and until you do it with your own hand, on your computer, then you can be assured. Right, because that is the basic condition in the data frame. Otherwise, it will multiply. Yes, yeah. Now using my basic concept, I can explain you what will happen. If your df1 and df2, they have this different number of objectives. Suppose it have only here 3 values and it has only here 5 values. Then when you are trying to join it, this 5 will come here, and then this 3 will come here, and this another 2 will come here. That will be repeated here. So that goes to the same operation which I shown you in the beginning when I was trying to create this one. You can see here this Y matrix, when I took it here matrix, that has only 4 rows. So in the data frame, when you are trying to create here, it will just repeat it 4 times. So this is what I expect from my basic concept. But still, I will request you that you just try to add here, suppose here 5,000 and here some state, and then try to do it yourself. Okay. Right. So that will confirm my conceptual findings. Right. Okay. So yeah. So now I have done these 2 parts, and the third part which is left here, that is R bind. So R bind will stack the values like the means vertically. So I try to create here these 2 data frames, say UP, MP, AP, JK, and population sizes like this, and then I try to take here another data set which has got different names, say Bihar, Delhi, and Punjab. So first the data set has 4 values, and another data set has 3 values, but the number of columns are going to be the same. So in this case, if you try to merge them together, then there should not be any problem, as you have just asked. If there are different number of columns, then possibly it will create a problem. So you can see here, this is my first data frame, this is my second data frame, and then when I try to use here R bind, then it is giving me this first data frame and second data frame here like this, and this is here the screenshot. So obviously, if there is here a third variable here, and if you try to add it here, then something will happen here. But I will request you that if you can just add one more column here in this data set and try to see what happens. Right. So is there anything else that you want to know about this data frame? Is otherwise I can go to the topic.
In this data set, is it possible to compare YOY year over year? Example, I'm giving the examples are, you have mentioned UP, MP, AP, JK. Okay, you take it as this is COVID cases of 2022. Okay, and there should be there are also COVID cases in 2020, 2021.
Yes.
A single sheet. Shall I know what is the mean of UP?
Yes. My answer is yes. Means from the single one, I just explain you.
Once background sound is coming.
Yeah.
Can you mute, ma'am?
Right. Okay. So if you try to see, the first thing I have just shown you, when I try to extract a particular variable from the data set. So that is the first option that you can do without any problem, that I just explained you on the R console. Right. Second thing is this: if you want to make a comparison, for example, you have the first column as UP. Then third column is the number of cases in 2020 and now in 2021 and 2022. And if you really want to see whether the number of cases have increased or decreased, you can create a query using the logical operators, in which what you can do, that those 2 values are subtracted, means 2021 minus 2022, and then if this number is coming out to be greater than 0, then it will indicate that it has increased. If it is less than 0, it will indicate that it has decreased. That can be done without any problem. So after this, that is why I'm trying to do this here, the logical operators, but for this thing you have to use the logical operations.
Thank you, sir. Right.
Another question, sir. May I
yes,
ask? We have a cbind command.
Yes.
And in merge, the redundancy of state name was removed.
Yes.
And the data was combined by column wise.
Yes.
Now in R bind, and the data was in merge, the data was also sorted.
In the
merge.
Yes, huh? Because you have an option here, sort. Yes, sir.
No. We didn't sort it. In merge itself, it combined the data and sorted itself.
No. It is actually, we had set it actually, if you try to see, there is an option here, sort. Right. So this sort has to be written here. Right. So the default value here is true.
Okay.
Right.
Okay,
Means
okay.
actually the sort is equal to true. It is the default. So that is why if you don't write anything, it will sort.
Okay.
But if you write down here sort is equal to false, then it will not sort.
Okay. So after R bind, again we have to sort it.
After R bind means.
After.
Achha, okay. Actually, yes. Okay, those things. Actually, you see, we are simply trying to copy and paste here. Actually, this. Okay, let me accept that is C bind, R bind, and merge. They have many options, right? The best thing is this: if you just try to go to the help and say help inside the help menu, if you simply type R bind, this will give you. Means all possible options are there, because at this stage I was just trying to remain at an elementary level. Then it can be done, and that is the So the first thing is this: you can do it inside this thing, and after that, once you have created this new data frame, after that we have function sort. Right. So you can also use the sorting function to sort the values separately also. For example, if you try to see in this MX Excel, if you want to sort the values, you have to simply press a button and then it will sort with respect to a particular column. Right. So the same thing can be in the data frame also.
As in MS Excel or in spreadsheet, we have different level of sorting. First sort by column A, then sort
that can be done in data frame also. Means if you give me a say one whole day on the data frame, I can explain you all.
No, sir. We have limited time. Proceed.
Yeah. So in fact, yeah, that's what I can acknowledge, that it is possible. Yeah. The only thing is this: you simply have to write one option in this command, and then it will be done.
Okay. Thank you, sir. Thank you, sir.
Actually, I think I can share with you. I am conducting the course for the offices of Indian Statistical Services, which are dealing with the data of the country related to different surveys. Right, and they are now, means I'm doing it for the last 4 or 5 years. So now many of them are quite confident and they are using it actually, because they want to sort it first with respect to state, then with respect to income, then with respect to family size and so on. So they are doing it actually. You're right.
Thank you, sir. Thank you, sir.
Any other questions?
No, sir. Thank you. Proceed, sir.
Thank you. So now I come to give you a very brief idea about the logical operators actually. So you know that what is the difference between the mathematical operators and logical operators. Mathematical operators will do the mathematical operation, like as 2 plus 3. If I say 2 plus 3, it will give me the answer 5. But if I say trying to say 2 greater than 3, then it will be, the answer is going to be either true or false. And in this one, this R, this capital means true and false written in the uppercase alphabet. They are the logical operators and they are the reserved words. So in the R software, you can do different types of logical operations, and using those logical operations, actually, many types of queries can be generated without much trouble. So I don't have time to give you the entire instruction that how to generate the queries, but surely I can give you a brief idea that how it can be done. So in the R, this greater than sign is the usual sign, which is used as a logical operator to find out the greater than. The symbol greater than or equal to is written here as greater than and equal to, like this, side by side. And similarly, the logical operator less than, it is the same in the R. This is less than, and similarly less than equal to here is like this, less than and equal to. And if you want to know exactly equal to, for example, if you want to know that 2 is equal to 3, the answer is no. So, but if you write down here mathematical 2 equal to 3, this has no meaning. But then if you try to write down here 2 double equality sign is equal to 3, then the answer can be true or false, right? And similarly, this answer what equal to, that is indicated by this exclamatory sign and equality sign, and the negation means not, then it is indicated by this exclamatory sign. And then there are here two more operators, this hypersign and this vertical line. Actually, this is a bar on your keyboard. So this and is used for combining the two logical operators. Suppose if you want to know that how many students are there who have got more than 70% marks in mathematics and 30% marks in chemistry. So then you have to use the operator here, this and. And if you want to know that how many students are there who have got either 70% marks in mathematics or 30% marks in chemistry, then you have to use this this vertical line, this bar sign. And yeah, there are, you have two options here, this and double and single vertical line and two vertical line. I will try to explain you with an example what is the difference between the two. And similarly, if you want to use that, means something like this, X or means either X should happen or Y should happen, like this type of thing, then you have command here XOR, and inside the parenthesis you can write X or Y. And then if you want to know whether any expression is true or false, then the command here is in lowercase and true in uppercase. Inside the parenthesis you write X, and similarly is for is false. So that will give you, suppose if you say is true 2 is greater than 3, means you want to know whether 2 is greater than 3 is a true statement or a false statement, then you have to work like this. You have to add like this. And true and false, they are the two reserved words which have to be used only as a logical operator. But remember one thing, this is only when you are trying to use in the uppercase alphabets. For example, if I try to take here some examples here to just try to show you what really happens. Suppose if I try to take X equal to 8 and then I try to take it here X less than 10 or X greater than or X less than 2, whether it is true or not. So 8 is less than 10, this is true, and this is 8 is less than 2, this is false, right? But then you have here that if the condition should be true, if either of the two condition is true, so that is why it will give you the answer here true, because this is true. And similarly, if you try to take here X equal to 18, then it will be 18 less than 10 or say 18 less than 2. So 18 is less than 10 is false, 18 less than 2 is false. So either of the conditions is actually both the conditions are here false. That is why the outcome will come out to be here false. So this is how we can actually check. Actually, these type of operators are needed when you are trying to generate different types of queries based on conditional execution. Suppose you want to know that which are the students in your class who have got say 30% marks in mathematics, more than 50% marks in chemistry, and less than 70% marks in physics. So these type of things will actually help you, right? And then yeah, means you can add here like this here, X can be used for physics, chemistry, and then this can be here. Yes, anything to ask? Okay, so the quickest can be marks in physics, this can be marks in this here maths, and then there can be another condition for the chemistry also. So these things can be done, right? Similarly, if you try to see here, suppose if you have two values 8 and 18, and you want to do the this operation on both the variables, then you can see here what happens when you are trying to use the this double sign and then here's single sign. So when you are trying to work on a data vector, and if you have a condition like X less than 10 or X less than 2, what you want that the control should come to here 8, and then it should operate. It should try to check the condition, and after that it should come to the next value, and it should try to whether the condition is true or false, right? But if you try to see the outcome, this is only here true. But on the other hand, if you try to take here this single vertical sign over here, then what will happen here? that it will try to give you here X, it will try to give you here true and false. So now what is the difference between the two? The difference is like this, that when you are trying to use the double operator, then it is working only on the first element. It will not go to the second element. So if you are working with a scalar, then it is a better option to work with the double line or double AND operators. But when you are trying to work on the data vectors, then one should always use only the single vertical line and a single AND operator. So you can see here, when you are trying to go for x less than 10 or x less than 2, then it is x is going to be first taken here as x equal to 8 and then x equal to 18. And then these two options are indicating for true and false here. Right. So that is because that is the same operation which I have done here in 2 steps that can be combined in a single step here. So that is the use of here single AND operator, because here you have used the double AND because it was a scalar quantity and it was giving you the correct answer. But when you are trying to use the data vector, then always try to use the single this operator. And the same thing is with the true with here and also, that if you try to take here x equal to 5 and then I want to take check here 5 is less than 10 and this 5 is greater than 2. So 5 is greater than 10, true, and this here 5 is greater than 2, true. So true and true is true, and this option and this outcome is here. Similarly, if you try to take here x equal to 15, so 15 is less than 10 and say 15 is greater than 2, 15 is less than 10, this is false, and 15 is greater than 2, this is true. So false and true is here. Means here false, right? So that is how this and then these two operator actually works. So that as I shown you here, that this is the same thing, that if you try to take here this x equal to x less than 10 with the same condition with the data vector here, then what will happen here, that it will try to work only on the first element 8 and it will give you the answer here 2. It will not come to 18. So if you want to work on a data vector, then as I said, you have to use the single ampersand AND operator, and now it will go here true and false. So this is the same statement which I shown you. The first answer was here true, second answer was here false, and when you are trying to do it with the double AND operator, it is giving you only the first answer. It is not giving you the second answer. But if you are trying to use here single AND operator, then it is giving you here both the answer. So as a rule, you should always use only the the single operator. Single operators will work on the scalar as well as data vectors. Right, now I try to give you here one more option, which I think some of you have asked, that okay, suppose I try to take here data sets, say 1, 2, 3, 4, 5, 6, like this one, and I want to see that out of this 1, 2, 3, 4, 5, 6, what is the condition that if x is greater than 2 and x is less than 5. So if you try to do it, then the operator will come on here x equal to 1 and it will try to check here 1 greater than 2 and 1 less than 5. And so 1 is not greater than 2, but 1 is this is here false and this is here true. So the answer here is false and this false is coming here. So this false is corresponding to 1. Then control will come to x equal to 2 and it will try to check the similar condition, and then the second value is going to in the outcome is going to indicate for the 2. Then third value is going to indicate the outcome for 3. Then remaining 4, 5, 6 are indicated by the remaining values here. So now, but this outcome is only the logical outcome. But suppose you want to know that what are the values in this sequence, or what are the values in this data set X which are greater than 2 and less than 5. Because if you try to use only this condition, it is going to give you an outcome only in terms of here true and false. So actually you want to see what is the outcome corresponding to the outcome true. So for that, the rule is very simple. You simply try to write down the value here X. Inside the square bracket, try to write down the condition. So what will happen here, that it will try to give you an output where the outcome of this operation is true. So you can see here, this is giving you here the values 3 and 4. Right, now if you try to see this very simple example that can be extended in multiple directions. Suppose you have this sheet, like first column is the name of the students, second column is their section, third, fourth, fifth column are the marks in physics, chemistry, maths. Now you want to know that which are the students who have got say more than 70% marks in mathematics, less than 30% marks in chemistry, and say more than 90% marks in physics. That condition of this marks can be written here using this and or operator, whatever you want. Now you want to know which are those students who have got such marks. So then instead of using here X, means I can write down here, say physics greater than 40 and say mathematics greater than 70 and chemistry less than 30. And now here you, instead of using the X, you try to write down here the column name for the student name. So it will give you here the names of the student who have got this combination of marks. So this is how you can generate the query. And if you want to know the answer only in terms of true and false only, then you have to use only the condition without using here X outside the square bracket. So that will give you the answer for all sorts of query. Any means any say complicated query that can be written in a single line here. That is the advantage of this R software here, right? And similarly, if you want to change the condition that you want to say out of this numbers, which are the number which are more than 2 or less than 5. So any number is either more than 2 or less than 5. So all the conditions are here true. And if you want to know what are the numbers which are satisfying this condition, the same condition is giving you here 1, 2, 3, 4, 5, 6. So this is how you can actually get the outcome of your queries actually. Right, and similarly, just to give you this idea that how this double and single and are working, so you can see here, this is here like this, that when you are trying to work with this double and operator, that is working only on the first value here, and that you can verify if you try to choose only the first value of the X and then try to use the same condition by writing X and then here 1, that will indicate the first value in the X data vector. So both these outcomes are going to be the same. So the moral of the story is that you have to just use the single and or single or operator when you are trying to work in the data vector, right? So I think now I come to an end to this lecture, because I always prefer that if the lecture is not finishing in time. So Anuradha had asked me to finish it by 10:30, so it is 10:30. After that, the audience becomes restless. So I have completed my lecture. Now, if you have any doubts or question, you can ask.
Sir, am I audible?
Yes.
Sir, can we perform joins on data frames in R?
Pardon? What?
Joins, sir. A natural join, outer join, inner join.
Yes. That you can do. Yes, that you can do.
Okay, sir. Okay, thank you.
So I think if there are no more this question, then I would prefer to stop this session and we will see at 4:30 p.m. Right. Thank you very much.
Thank you, sir.
Next lecture will be at 2 p.m.
Ma'am, next lecture is on 11:30 or 2 p.m. Radha ma'am, next lecture is on 11:30 or 2 p.m.
Sir, as per schedule, the next lecture is scheduled at 11:30, but I'm confirming from Anuradha ma'am right now. As soon as I will get the confirmation, I will tell you.
Nini, what happened? Sorry, I was on phone call.
Ma'am, the session is over. Sir has already left, and I think yes,
okay,
ma'am.
okay.
Yes, ma'am.